Typesense, if you have heard of ElasticSearch or Algolia, we position Typesense as a open source alternative to Algolia or a easier to use alternative to Elasticsearch. Um, because if you want to store your data in a RDBMS, that's a very straightforward way. That ecosystem is pretty mature now. You have ORMs, so it's very easy to store it in Postgres or MySQL, and that whole problem is solved in a very good way, right? Look at the way basic search engine works. It's an inverted index. So you have a term and then you have a list of documents that they occur in, right? And on top of that's the really fundamental of the whole thing. And on top of that, you will store for every token in which positions they occur in the document. So it's a large hash map or a token to list of document inverted index. And for a long time, storing that kind of index is like a very it's memory intensive to do it very fast. So the Lucene is like the underlying engine for all the Elasticsearch, Solar, and all these other open source projects. They all built on top of Lucene, and it was built in a time where memory was very less, so everything was on disk data structure. And then time really flew, right? And memory just became really cheap, but there was not much innovation on that front at all. Also, I think this is my hypothesis. The way we have started consuming data has also changed. We have iPad, we have mobile phones. The screen size is much smaller now than what it used to be typically. So you are now more into instant search and things like that, where you do not want to hit a enter. Like in a mobile phone, you only having a button for a search is that itself is takes up a screen real estate. So people want to do that kind of interfaces, and that is kind of driving innovation in this space, whereas it used to be primarily desktop, where you don't make much typo mistakes because you have large keyboards. So yeah, it's basically a multitude of factors. One is memory become really cheap for you to be able to do this kind of stuff, and also the use cases emerging for you to kind of push the boundaries towards. So I would urge you to go check out the demos on typesense.org. I can, instead of telling you these are the use cases, I can share with you some of the things that we have done. So obviously e-commerce is one major use case in terms of what you can use Typesense for, because search directly converts to revenue there, and there is study that clearly relates to latency in searches to conversion rates and so on. So it literally literally prints money there, right? So e-commerce is one a major use case, and but anything that you need an interactive, for example, you are let's say you are a health and fitness app, right? And you are allowing users to choose their diet plans or something like that. Then you're going to give them a list of healthy diets, and they start searching on it. Let's say they type egg or spinach or something like that, and you again will want because they are exploring the food, and they are making decisions, right? So wherever instant search and exploratory UI is is needed, that's where it is that's where it types in. So we have an integration with the doc search plugin that Algolia has. It is basically a front-end framework that integrates with Algolia. We have an integration that integrates doc search with Typesense. So that is one. So you can look at basically the Algolia doc search examples. Whatever you can do there, you can do it with Typesense. And we also have plugins. We just released one plugin for Docosaurus, which is a popular documentation engine framework. We released a plugin for that. You can maybe check that out. So and we will be launching other integrations with other static site generators like Jekyll and Hugo and so on. But right now, Doxorus is what the plugin we have, but it's just a matter of, you can just write, because most static sites don't change that often. Only when a blog gets published or something like so. As part of the build process, you can just have a script that just calls Typesense and indexes it. Yeah, that's how it would work. I'm running a Shopify site, and if you look at the Shopify merchants, most of them will have very little SKUs, very little products. So they might be selling 10, 15, 20, 50. That's it, right? So I might very well use Shopify for the backend, but I want to use Typesense for the search. So how do I synchronize the inventory in Shopify with what is on Typesense? So that could be one angle that you can take, and then X versus Y, right? So you will do the same for Magento, do the same for WooCommerce, and so on. That would be a good thing. And maybe you can start off with one general article about how would you create a e-commerce like a site. We already have an e-commerce demo site that uses instance.js. So maybe you can start with that, like maybe get a schema or something like a basic schema, and then you can deal with like how you pull the data from different e-commerce sites into this. A lot of it will tie to headless CMS, which is the rage these days. There's a bunch of single page apps or headless e-commerce that are coming up. There's Versal e-commerce, they have a thing, and then if you just type headless e-commerce GitHub, you will find like a lot of popular projects that are springing up. So that could be another angle too. And again, there is a huge scope for an integration there, which kind of will fall into the other bucket. So we are focusing on more geo search. We just launched geo search in the last release, but we're going to take on more features in that. Like right now, you can only store and search on a single geo point. We're going to support storing on a bunch of places. We're going to probably start ability to index areas. Right now, we can only index points. So geo search is one place, and then we are also in future will want to work on like recommendations, right? Because and also try and offer more more scope for personalization. It might be something that you might still need to feed the input into Typesense, because Typesense is not going to have like the full data about your users and so on, but we want to give knobs so that you can like personalize the results to different sets of users. So those are two main thing, and obviously the performance improvements, making it work on larger data sets and like memory reduction. Those things will carry on as a like an infrastructure track. From a feature track, I think these two are the large ones because this will basically fill our roadmap for a few months, because personalized search is a huge topic. There is a Linux subsystem for Windows that you can use to run. Some people have done that. And if you use on Mac, we have a Mac binary. But really, our target system is, we just recommend people use Docker if they're having any issues. But our target system is Linux. That's what we focus on. The demos will cover most of what you're like. There is a Linux commit search that will be very close to like a pure text space search, because some of the other demos are more structural, like the e-commerce will have like facets, filters, and so on. In terms of like a pure search, I think the Linux commit search will come close to that. I think one of the challenges with a full text search on just like a search database, just like a database of text, is how do you do ranking, right? Because that's a little different. We do not handle that part. Like Elasticsearch will have something like TF-IDF and term frequency based matching and so on. We don't do that. That is something that we leave it to the implementers to figure that out. Like mostly TF-IDF is junk. That's what I have seen. Usually there are much better metrics to go by. Like um, uh, if you have like popularity of the article, like let's say it's a blog or something like that, you will definitely have page views associated with it. That's a good way to like find out like the popular ones. So that's something that you might have to think about. How do you like sort your results based on relevance? You have like a word like JavaScript, so it can appear in hundreds of documents. How do you like which document containing JavaScript is more important than something else? Elasticsearch solves that using TF-IDF based on frequency and all that, but that's not always like a good proxy.